In this video, we will understand how we can formulate the linear programming problem. First of all, we'll understand the mathematical model of linear programming problem. Which is written as, firstly, we'll identify our objective function, and it is written as optimize, which is either maximize or minimize. And we write it as z is equal to sigma Cj xj, where j is from 1 to n, and it will be subject to the constraints. That is, our first work is to identify the objective function. Next, we'll formulate the constraints, and our constraints will be sigma aij xj. It can be either less than or equal to, or greater than or equal to bi, and here I is from 1 to m, and xj will be greater than or equal to 0. Here this xj is our decision variable, cj is the coefficient which is the per unit contribution, then this aij, it is the input output coefficient of our decision variable, and this xj greater than or equal to 0, that is known as the non-negativity condition. So each and every time we have to formulate the linear programming problem, then this will be our model. Now let's understand this with the help of this example. A company sells two different products A and B, making a profit of rupees 40 and rupees 30 per unit on them respectively. They are produced in common production process and are sold in two different markets. The production process has a total capacity of 30,000 man hours. It takes 3 hours to produce a unit of A and 1 hour to produce a unit of B. The market has been surveyed and company officials feel that the maximum number of units of A that can be sold is 8,000 units and that of B is 12,000 units. Subject to these limitations, products can be sold in any combination. Formulate this as a linear programming model to maximize the profit. Here what is given to us? We have to formulate the model to maximize the profit. Hence it will be maximize z is equal to. And now for profit, what we'll see that A makes the profit of rupees 40 and B makes the rupees 30 profit. So firstly, we'll define our decision variables, and here I'm taking it as x unit of A and y unit of B. That is, I have taken for A, I have taken it as x, and for B, I have taken it as y. So x unit of A and y unit of B be produced. You can even take this x and y as x1 and x2. Now we know that for A it is 40, so it will be 40x. And then for B it is 30 rupees, so it will be 30y. That is 40x plus 30y. This will be our objective function. And then next we'll formulate the constraints. So we'll write it as subject to the constraints. From the question only we'll able to formulate the constraints. That is, here as we can see that it is 30,000 man hours. The total capacity is 30,000 man hours. For A it was 3 hours and for B it is 1 hour. That is, the production of A takes 3 hours, which I can write it as 3x, and production of B takes 1 hour, which will be y. And then the total capacity is 30,000, which means it will be less than or equal to 30,000. And our next constant will be, here it is written maximum number of units of A that can be sold is 8,000, which means that X is less than or equal to 8,000. And the maximum units of B that can be sold is 12,000, which means that my Y will be less than or equal to 12,000. And then we'll write the non-negativity condition, which is X and Y greater than or equal to 0. Let's solve one more example. The question is, the Agricultural Research Institute suggested the farmer to spread out at least 4,800 kg of special phosphate fertilizer and not less than 7,200 kg of a special nitrogen fertilizer to raise the productivity of the crops in their fields. There are two sources for obtaining these mixtures, A and B. Both of these are available in bags weighing 100 kg each, and they cost Rs 40 and Rs 24 respectively. Mixture A contains phosphate and nitrogen equivalent of 20 kg and 80 kg respectively, while the mixture B contains these ingredients equal to 50 kg each. Write this as a linear programming problem to obtain the required fertilizer at minimum. So our objective function will be minimize Z is equal to, and here the cost has been given to us, which is 40 rupees and 24 rupees. Firstly, we'll suppose that X and Y be the number of bags of the mixtures A and mixture B. Then as we have to minimize this, so our goal is to minimize the cost. Hence we'll take this as 40x plus 24y, because mixture A cost is 40 and for mixture B cost is 24. That's why we took it like this. Then we'll formulate the constants. See, in the question it is given that we have to spread out at least 4,800 kg of special phosphate and 7,200 kg of special nitrogen fertilizer. And for mixture A, we have phosphate and nitrogen equivalent as 20 kg and 80 kg. And for mixture B, both of these values are 50 kg. So how will formulate this? 20x plus 50y, that is mixture A plus mixture B. And again we'll take the mixture A plus mixture B, and this time mixture A is 80x and mixture B is 50y, and then it is written at least, which means we'll use the greater than equal to constant. First one will be greater than or equal to 4,800, and my second constant, that will be greater than or equal to 7,200. The first one we have made on the basis of phosphate requirement, and the second one we have made on the basis of nitrogen fertilizer requirement. And then we'll give the non-negativity conditions, which is x, y is greater than or equal to 0. So this is how you can formulate the linear programming problem. I have also given the solution to both these problems on my website. You'll find the link in description. Thank you.